Okay, here comes the second half of the even numbered problems on the test. And as I've already put them on the board, some of the questions are, well, I'd like to have asked something else, but that's okay. So, inequalities, we've been mostly working with sign charts. So when is something greater than zero? A division is greater than zero when I have two positives or two negatives. And so let's find out when that happens. So the critical numbers are 5 and 3. There's 5, there's 3. And I know these are going to change signs. That's the shortcut. So I put a number bigger than 5 in. That makes that positive. Bigger than 5 makes that negative. So no. So this is going to be yes. That's going to work. This is going to be no. We got to be careful of division by 0. So 3 is a no. So what do I have? I have X numbers that are bigger than 3, but less than or equal to 5. All right, that's when this is going to be bigger than 0. All right, the shortcut here is to, in your mind's eye, cut that number in half. So therefore the center is going to be at -8, y plus 4, so that's y plus 2. If I cut that in half, that's going to be -2. Squaring these 64 and 468, take away 464, so your radius is 8. And now I'll do the whole problem out. Well, x plus 8 squared minus 64 plus y plus 2 squared minus 4 equals -4. I hope you can see those cancel. Bringing the 64 over to the other side verifies that your radius is 8. And -8, -2 is going to be the center of that circle. The inverse of e to the x is ln of x. I hope you know that. Let's divide everything by 2. X squared minus 2x. Let's bring the 30 to the other side. So -15 equals 0. You can see that that's factorable. X minus 5, x plus 3 equals 0. So the numbers that work are 5 and -3. Got an eraser here, which is good. So I will erase that now. You can replay it. Subtraction of exponents comes from a division of quantities. So this could have been written as a single log. Thusly, x over x minus 4 equals 3. The inverse of log base 2 is 2 to the, and the in this case is 3. I'll use the eraser here now. So 2 to the 3 is 8. So x equals 8x minus 32. I'll take an x away from this side. I'll add the 32 to this side. And I'll say that my answer is 32 over 7. All right, so that's the answer to a quadratic. You pause the video, try it. I want to get to ax squared plus bx plus c equals 0. Well, 0 on this side means I'm moving things over to the left. Let's start with x minus 7 equals plus minus 2i. Let's square both sides. X squared minus 14x plus 49 equals 4i squared. 4i squared is -4. Let's bring it to the other side. And your answer is the following. Okay, and this is not going to take long to make this video, so I might as well go back to that. But this is your answer right here. Well, let's go in the other direction. Let's complete the square and see where it comes from. So first thing I'm going to do is write that as x minus 7 squared minus 49 plus 53 equals 0. So that's x minus 7 squared is equal to +4 on the other side becomes -4. Right, and I hope you can see where the plus minus 2i is going to come and where -7 becomes +7. All right, equals 16. So I'll just pretend that's a parentheses and see how far I am from the number 4, because that's going to be the center of the V, 4. And whatever I am to the right, I'll do to the left and vice versa. 21, 7, 11. Okay, so if I put 11 in, I get 21 minus 5 is 16. How far is 11 from 4? 7. So my answers are 7 from 4 on the left, -3 and 11. This is one of the dumb questions I asked. All right, so get P alone. Well, I think we're multiplying by e to the RT. Maybe I thought it was a good question. I don't know. I asked it. And there's your answer for that one. 16 and 8 have 2 as a common base because there's no rule of exponents for different bases. So let's make this 2 to the 4. Let's make this one 2 to the 3. What am I doing to these numbers? Raising that to the x minus 1, raising that to 2x minus 4. That gives me the equation 4x minus 4 equals 6x minus 12. I'll bring the 4x that way, make it 2x. I'll bring the 12 that way, make that 8. Looks like my answer is x equals 4. Might as well see how it works. Nah, let's not see how it works. Well, maybe. If 4 minus 1 is 3, 2 to the 4 to the 3 is 2 to the 12. 3, 4, 2 times 4, 8 minus 4 is 4, and 2 to the 3 to the 4 is 2 to the 12. So that worked. All right, so we have a cube root here. I know 40 is 8 times 5, so I am going to take the cube root of 8 and call it 2, but I'm going to leave the 5 there. I'm going to divide 3 into 6. I'll take 2 out. Divide 3 into 33. I'll take 11 out. I'll divide 3 into 25. I'll take 8 out, and I'll leave 1 in. Okay, I hope you can see that. 16. ln of 16 is actually the ln of 2 to the 4, which is equal to 4 times the ln of 2. So my answer is going to be 2.8. That's the approximation, but we'll do it out. Not using rules of logarithms, but hopefully seeing where the rules come from. 16 is 2 to the 4. 2 is e to the 0.7. Hope you can see 4 times the ln of 2. But there's your 0.28. So that's what I'm hoping you write. 2.8. I hope I said that correctly. All right, now we're going to work with the rules of logs. Come on, Renee, we got the same problem here again. Traffic jam right there. So division implies subtraction of exponents. So ln of 5 minus ln of 6. I hope you can see that 6 is 2 times 3. And multiplication is addition. So I have the ln of 5 minus parentheses ln of 2 plus ln of 3. That's a nice way to write it. Or you better subtract both. Minus the ln of 2 minus the ln of 3. All right, so this is an interesting question. This is f of y equals x. Instead of f of x equals y, we have the inverse of a parabola. And the inverse of a parabola is not a function in terms of x. So how would we write this calculation? Well, we go back to basics, but let's work with the y values. So I got y minus 3 squared. And I want to get a 2 for x. But I plug in a 3 for y. I just made that happen. Now I plug 14 in for y. 14 minus 3 is 11 squared. That's 121 units of change. But I want to go from 3 to 14. I hope that 11 units of change. Well, so it's 1 over 11. But if you want to leave it like that, I was just checking your thought process. All right, and I'm going to standardize e to the x. We standardize our graphing. Right? I hope you spot exponential decay. So I'm going to have a 3 to 1 ratio here. And I know that that's going to be my initial jump of 4. And so that's going to be 3 times that. And I know I got y equals 5. Now I'm going to erase this, but I'll put in 5 plus 12, 17. It's going to get me a point over here. And 5 plus 4 is 9. I'm going to get a point there. If I pick the right x values, that's going to happen. And so I'm going to be at 1 to 3. That's not too bad as a drawing. A 3 to 1 ratio. Okay, so what do I want to pick? A 0. E to the 0 is 1. 4 plus 5. Oh, I'm doing this one. I'm so used to doing growth. Okay, so that's this one. First jump is 4. So 0 gets me 9. Okay, and now I want minus x to equal 1.1. So I triple this distance. Okay, so why don't we shift the x over there? And let's put the 1.1 here. And it sure looks like if I put 1.1 in, I'm sorry, negative 1.1 here. I almost forgot to do that. If I put negative 1.1 in and I take the opposite of that, I get 1.1. And e to the 1.1 is 3 times 4 is 12 plus 5 is indeed 17. And negative 1.1 is to the left of 0. So now, good. Talking about it, done with it. So let's erase that, and then we'll graph this log. Maybe come at it from a little different perspective. I hope people recognize it as a log. Okay, sure, it looks like a base 3. So, oh, I'm graphing. I already got the equation. So what do I see? I see x equals 1 is being highlighted. I see a base that is the inverse of growth. I know that I can make this thing equal 0. I can make that equal 0 because log base 3 of 1 is 0. And 0 times any multiplier is gone. So I'm going to get 5 out of this if I correctly pick the right number. And I'm going to pick, because I want a 1, I'm going to pick 5. 5 minus 1 is 4. 4 divided by 4 is 1. What's log base 3 of 1? Big fat 0. Okay, so I'm actually picking 5. And if I look at from 1 to 5, I know that's 4 units. So I know that's got to be 12. So I'm going to pick 13. 13 minus 1, 12. 12 divided by 4 is 3. What do you put on top of a 3 to get a 3? Oh, I created the number 1. And I got a constant here. I think I'm going to add m plus c. I think I'm going to add 2 plus 5 and get 7. And I think I picked 13. Yep. So log base 3. I want the parentheses to equal 0. That gets my asymptote. That whatever makes that 0 gets the asymptote. Log base 3 of 1 gets me c, gets me the constant. And log base 3 of 3 is going to get me 2 plus 5, m plus c. And if you keep doing these, that gets pretty quick and easy. All right. Let's get our range here first. Put that 5 there. Let's go up 3. Let's go down 3. Okay, so that's that. It's very important to know what the cosine of 0 is. So we want to make a 0, -2. Okay, what's the cosine of 0? Well, 0 is that place on the circumference, and I guess I'm asking you what the width is in the unit circle. What's the width divided by 1? Hope you said 1, which is the maximum width. This is maximum W on this side, minimum W on that side. Okay, so I'm going to max at -2. I'm the cosine of 0. So cosine of 0 is 1. And 1 times 3 is 3 plus 5 is 8. I'm right here, and I'm going to come back to there. And I know I'm starting at -2, and I know my period is 2 pi. Why? Because my multiplier is 1. And I put that under 2 pi. And every time I change 1, every time this thing changes by 1, I go around the circle once. So what changes this? Well, that's a 1, right? So let's put -2 plus 2 pi in here. -2 plus 2 pi. What happens to the 2's? They cancel. What's the cosine of 2 pi? I'm back to the max. That's what I'm hoping to see. Now we'll do the sine function. And it's always nice to know what the cosine of 0 is, what the sine of 0 is, all that. 0, such a friendly number. So here I am on the circle at 0. Okay, and I'm measuring heights. Well, heights go up to 1, they go to -1. If I'm there, I think I'm in the middle. And if I'm in the middle, going up, well, if I'm in the middle going up, I think I got the rest of the sinusoid. So I look for the 0, -3. I'm going around the circle. You're going around at this speed. I'm going around twice as fast. That means whatever it takes you, I'm going to go twice as far. Is that what I wanted to say? Not sure I wanted to say that. Anyway, -3 is where we start, and that's a height. I didn't put my heights in. 3, going up 5, going down 5. There's my range, -2 to 8. Sine function -3, and if I'm going twice as fast, it takes me half as long. That sounds better, right? So I know that I'm at -3 plus pi. That's the period. How do I find the period? I take the multiplier and I divide it into 1 revolution. Okay, so those are the hard things. The hard things is knowing where to start, what the shape is, and finding the period and adding the period to the starting position. So every 3.14 units instead of every 6.28. So every 6.28 might look like this. Every 3.14 looks like that. And then another one like that. Twice as fast. All right, so I guess I got to put in -3, that location, -3 plus pi, that location. So -3 plus pi over 2 is that location. And -3 plus pi over 4 is this one. And it should get us 8. I think it's worth doing that one. So let's write 5 sine over here. Let's do 2 times our answer. Our answer is -3 plus pi over 4. Okay, what happens when you multiply 2? And that should be parentheses here and here. 2 times -3 is -6. -6 cancels with +6. 2 times pi over 4 is pi over 2. What is the sign at pi over 2? The sign at pi over 2 is the top of the circle. That's 1. 1 times 5 is 5, plus 3 is 8. I hope you can see how those values are being assigned. All right. So what do I see? I know I'm going to have a XY axis. So let's put X and Y here. Let's pick a number. I'm going to pick 0. 0 gets me 5/8, so I'll call that 0 5/8. Let me make sure I'm going to put this on the correct side. 0 5/8. I know at -4, I've got an undefined situation, -4. I know there's no x-axis. There's no way to make this equal 0. Right? Division by 2 plus 8, multiplication on this side. And I don't think that 5 equals 0. No, can't use -4. I look at this and I say, oh, it's going to 0. Yeah, it's kind of like one of these y equals kx problems to me. Kind of looks that way to me. Inverse variation. This gets bigger, the fraction gets smaller. Oh, I can see this. Let's verify that. Let's put -3 in. And let's see if we get an answer that's a little bit bigger than 5/8. -6 plus 8, 2. 5/2, 3.5. Okay, I can believe that. That looks good. Okay. And what happens? We get a sign change at -4. And therefore, if we go to 0 on this side, sure looks like it's going to look like that. I'd say that's what it looks like. I should have put it a little further to the right. Not going to change it now. So what happens is I move to -4 from the positive side. Well, I hope you think numerically first. So what is a number that I would put in that comes from that communication? I'm going to pick things like -3.9999. And if I double them and add 8, I still think it's going to be a positive denominator, but I'm going to generate things like this. Looks like I'm going to positive infinity, which we could have seen from the graph. I'm moving towards -4, -3.999999. It's getting me a huge number here. Getting me a huge number. Then we get a sign change. So if I came in from the other direction, I would have gone to negative infinity. And if I came in from both directions, I'd have to say that limit, I can't tell you where I'm trending. I'm going in opposite directions. Then we would say, does not exist. DNE. I kind of covered the 3 situations that are most interesting to talk about initially. Let's do it again. Got another rational function. What do I see? I see that I'll write it a little more to the right this time. I see a 2-to-1 ratio because they're the same exponent. They're the same exponent. Which means I have one function that's going up at 2-to-1, one that's going up at 1-to-1. And as I get way out here, those initial local values don't matter. That divided by that is coming to me in a 2-to-1 ratio. Try to layer that with a little concept. So over here, I get y equals 2. Over here, I get y equals 2. Then the undefined is -5. And the y-intercept is negative in this case, -12/5. And this one does have an x-intercept at +6. I can see this now. And there's no more x-intercepts, just a 1. That's to the first power, and that's to the first power, so I'm going to get a sign change. So what was negative is now positive. And it looks like that. Yep. And so what do I move towards? This g of x is like saying y. What can you tell me about the y values as the x values get really, really big? Well, here's the big x values. Sure looks like I'm heading to 2. Like that's heading to 2. How about as x goes to 0? Well, as x goes to this number, I see nothing wrong, no undefined situations. I think I'm going to hit table values getting closer and closer to -12/5. Get as close as you want. And the closer you get, the more you might as well say, I'm heading to -12/5. And what happens as I head to x equals -5? Well, same problem. I'm coming in different directions. Does not exist. If I came in from the right, heading to -infinity. If I come in from the left, smaller than -5, number smaller, but getting closer to -5, I'm heading to +infinity. As I come in towards -5 from both directions, does not exist. All right, so that didn't take all that long. I'll upload this now and share it with you later today. And you don't need me to say that because you have no idea what time it is here. Okay, toodaloo.